Hello, participants. My name is Joshua. Having introduced the concept of time series, as well as a few basic aspects of the theory, we want to quickly consider how to visualize time series data. And I want you to please pay attention because whatever we learn from this slide, we are going to implement using our R&R Studio platform. Visualizing time series data is always the starting point of any form of meaningful time series analysis. And if you want to do that using R, the starting point is to set your working directory and install and load or download the data set. Some of the packages of interest include tidyverse to manipulate our data frame. We have forecast package for plotting our graphs as well as making some forecasts. We have Zoo for manipulating time series data. We have Write Excel in case we want to export some of our results to Excel. Then we have ggpub. This is very useful for us when we want to write the trend equation as well as the coefficient of determination on our plots. We are going to start by using COVID-19 data. I'll get the data from covid.ourwortdata.org. So I will show us how to download directly from the website into our console. So I name it COVID. You can give it any name of your choice, and the function you need to import into R is read_CSV, and this is just placing this website in a quote. The moment you have that, then you need to extract the data for your country of interest because you know you have the COVID data cover almost all the countries in the world where COVID-19 is a problem. To extract, I called the new data sets NIGD. This is the COVID data. So I have this chain operator. And in layman language, this chain operator means then what do you want to do with COVID? So I want to filter. Location is the column name where you are for the countries. So I say, okay, select Nigeria. Then I need the data from, I think the data starts from February. I need it up to June. This is what this is telling me. Then select, because we have so many variables, just select just these three. I need the location, the dates, then my variable of interest is the total number of cases. This is the name of the column. Then after that, I say, okay, please export this data set I've generated on Nigeria to my working directory and call it nigd.xlsx. That's what I've tried to do here. We see how to do it better when we get to R. The next thing is to plot your graph. And before you plot, the starting point is to convert to Zoo data so that you can define the dates appropriately. So I call that one the new data set with converted to Zoo as NIGD_Z. So I say Zoo. This is, I'm interested in total number of cases. So this is my date sequence from 2020 February 1. And up to 2020 May 30. Say bar equals to 1, which means I'm considering a daily data set. So after that, I auto plot. This. Then I define a discrete for my x-axis. I say, okay, give me the dates on monthly basis. And this is months. And in the terms of the label it as the months and the year. So then label my y-axis as number of cases and my x as time. You've done that, then you get this graph. It's actually showing us a kind of increase in the number of cases uh, over the time we have selected. And we can add our trend line and equation to the data set as well, the R squared. That is the essence of the ggpop. You want to do that, this is, we just add the geom smooth, this is linear method, plus the regression equation. I want the label to be in front of where my y is equal to 20,000. This is why I say label.y. Then this is start underscore call. This is the function to define my coefficient of determination, my R squared. So I label as R label, then label. I want it to be where my y is 18,000. So this is what I'm trying to say. Yeah. So this is the result, and it's actually showing a kind of rising trend over the period we are selected. Then we are going to look at how to use Quindle package in order to download data also from the websites. That's another very good package for downloading data directly from websites. And then, we may be interested in aggregating our daily data to either weekly or monthly. If you want to aggregate, for instance, to monthly, this is, we converted the data to zoo, so I want to convert it back to data set or data frame. To do that, the function is fortify.zoo. So this is just, I still add this one for me to be able to look at the 4-6 observations. Then I want to break the dates into year and months, since I want to aggregate the data to monthly. So in trying to do that, this the way to do it. So in the zoo data, the date is changed to index. So that is why you have index here. We will see it more clearly when we are dealing with it in R. So I break this. I now have a column year, I have column months. Then this aggregates. As I aggregate this data, so I have column for month, column for year. Then the function, I say sum, that is, I need the total for each month. So this is, if you have done it correctly, then with this you get the 4-6 observations to be sure that you've done the correct thing. So that takes us to how to plot monthly data sets. And for this case, we are going to use another data set, climb that. I think I've sent it to all the registered, all the participants that's registered and paid. So the starting point is convert this maximum temperature there to time series, and that's pretty simple to do. Give it a new name. That's, I call it tx underscore ts, because this is, use tx to do the conversion. So this is my data set here. starts. So this my starting point is 1979 January, and the frequency is 12 to indicate that I'm dealing with monthly data. And to see the time series data, this is TX, just type this, then run. Then you can plot it, just auto plot. Then this, I label my y-axis max temperature. We've done that, this is what you obtain. It's pretty clear. Then I can add the simple moving average. This is my center moving average, defined over 12-month period. To get a clearer view of the trend, I can remove the seasonal effect. To do that, I aggregate the data to annual level. So to do the aggregation, just aggregate this the name. I call it so aggregate, then this is divided by 12 because remember we are dealing with temperature. So you can't be summing temperature. So this is why I divide by 12 so that I get the mean temperature. So this is it. Then if you want to plot, you can now see this is the trend. Super simple. Then we can look at, we can extract the season for each item of the data using box plot with cycle. To do that, say box plot, this is our data set. Cycle, that is, this is talking of 12 months cycle. You can use any color of your choice, but I've tried to select red. If you try to do that, these are the various months here. So, and you see the line here is talking of the median, and here you are talking of here and here you are talking of the first and the third quartiles, and all these up here, down here, they are the variation. So if you want to look at it carefully now, you can see that it is around July where you have the lowest maximum temperature, and in terms of the hottest months, you are talking of let's say November up to February. Yeah. And at times, our interest may be just 1 or 2 months rather than looking at all the months. If that is what we want to do, we can extract by using window. So this is what I try to do here. I want to extract January. Okay, I call it Jan TX. Say window. This starts. The only thing I need is this January here. My frequency is true. In this case, it's going to give me the data set just for January alone and nothing more. Um, Another thing we quickly want to look at is the composition of the time series itself. And by the time we are considering the concept, we say we can decompose to trend, to season, to random, and so on. Then we try to look at the two types of model, the additive as well as the multiplicative. So in terms of, if we are interested in decomposing, it's very pretty clear and simple to do. Where I call it decomp underscore climate equals, the function is decompose. Then after doing that, then I auto plot. So you can see this is our data sets. This is the trend that we obtained at that time. So this is the seasonal variation. And here you have the remainder. We can call it the random. So you can see that the trend cycle, you can see, is somehow non-linear. Then you see this seasonal component seems to even out over the analysis period. And you can see that, yeah, it doesn't look, I mean, the remainder here, which is the random variation, doesn't actually look like random noise. Another thing we can do is to extract the seasonal plot for various years. So to do that, you use GG season plots in forecast package. So this is So you have um, different lines for each year. So it's so simple to isolate the seasonal pattern by so doing. So, for instance, if you look at it, there is always lower temperature in July. You can see it clearly here than other months. And temperature, you can look at it, tends to decline from January up to June. And you can see a kind of rising trend from July up to December. Yeah. Another way to look at seasonality is through the plot of the autocorrelation function. If the data has no trend or cycle, then the autocorrelation function plot will show some kind of rapid decay. Why if it has no repeated pattern, then we can say that there is no seasonality. In our case, we can see both slow decay indicating trends and a cycle, and we can see some repeated patterns up and down, and they're indicating some kind of seasonality. We can look at how the plot looks like for different lags in order to look at um, the magnitude of the variance. So you look at this, you can see this plot actually suggests that variance increases with magnitude in some months, but decreases in some months. Particularly, there is variance increase with higher lags. You can see. So, and these are a few things. We need all this kind of understanding of the pattern to really know what to do, what to correct for, and so on and so forth. Maybe at times we may need to take the log in order to remove the variance and so on and so forth. And we may need to maybe take kind of force differencing in order to correct for autocorrelation and various other problems that may arise. So we'll see how to do this better by the time we look at the data sets in R and R Studio. By now, I think all of us have R and R Studio installed on our various computer system. Because after this, I'm going to give us assignments. You are going to make use of a monthly data set and try to explore whatever we have learned, and we'll come back again to see how we see or how we have tried to understand um, the analysis.